Hey guys, welcome back to another video. In this video, I am taking Fourier transform of unit 2. So over here I have taken Fourier integral representation. So this is one example. So I will tell you all how to solve this example. So let's start. In this sum, our question is f of x is, they have given 1 and 0 and they have given the limits over here. Then they have told also find integration of 0 to infinity sine lambda cos lambda x upon lambda d lambda. Now they have not told us exactly what to do. So over here what we will do is, we will first take the even function. We'll find the even odd function of this f of x, and with that we will come to know whether if it is an even function or odd. So according to that, if it is a even function, then we will remove fct, and if it is a odd function, then we will remove fst, that is Fourier sine transform. So let's start with the sum. So first we'll write f of x. So we have f of x as 1 and 0, and the limits are x mod 1 and x mod greater than 1, less than equal to 1 and greater than 1. So now we will find whether this is an even function or an odd function. Then we have to put f of x is equal to minus x. So then that is, put x is equal to minus x. When we put x is equal to minus x, but in this both places we don't have a x, so therefore f of minus x will be f of x. Therefore this is an even function. As it is an even function, then we have to find fct, that is Fourier cosine transform. So first we'll find Fourier cosine transform, and in the question if you also know, now when we have d lambda, it means we have to find the inverse. So over here we are finding fct, and also we have to find ifct, because we don't have x over here, we have d lambda. Now this line is very important, as this decides whether we have to find fct or fst. So please pay proper attention to this part. So then now we have to find fct, that is we have to find fc of lambda. This is what we have to find, and the formula is integration of 0 to infinity f of x into cos lambda x dx. So f of x is 1 and 0. Now we have to take both. There are two f of x over here, so we'll take them. Integration of 0 to infinity. So we have the limits as they have given. It is x mod less than equal to 1. It means it is, the limits are from 0 to 1, because they are saying that it is x mod will be less than equal to 1, means it is up to 1. So from 0 to 1 it will go. So then over here f of x is 1 into, we have cos lambda x dx. So we can solve this. 1 into cos will be cos, therefore integration of 0 to 1 cos lambda x dx. Now we have to do integration of cos lambda x. So the integration is sine lambda x upon lambda. Limits are from 0 to 1. So now we have to put the limits for x, because this is with respect to x. So then we'll do that. It is sine lambda 0 upon lambda minus, that is lower limit, sorry, the upper limit should be first. So over here it will be 1, upper limit minus lower limit. So 1 minus sine lambda 0 upon lambda. This is the upper limit minus the lower limit. Then we have 0 into anything will be 0. So sine lambda upon lambda minus 0. Therefore sine lambda upon lambda is fct. Now we have to remove the inverse, that is ifct, inverse Fourier sine transform. Now for ifct the formula is 2 upon pi integration of 0 to infinity f c lambda, that is this answer, the fct, into cos lambda x d lambda. So now we have to substitute the value. We can put 2 upon pi integration of 0 to infinity fc lambda will be sin lambda upon lambda into cos lambda x d lambda. Now in IFCT we have to find f of x. So now what we will do is, we will take this 2 upon pi that side. So this will become f of x upon 2 into pi. Then it is equal to 0 to infinity sin lambda upon lambda into cos lambda x d lambda. Now if you see the question, over here it is written also find sin lambda cos lambda x upon lambda d into d lambda. So over here if you see, this is matching. See, this is the question, sin lambda cos lambda x. So over here we have the same thing. So now we have got this statement. So this is called as, this is Fourier integral representation. This is Fourier integral representation. So this is what the answer is. So now last thing what you have to do is just to represent it properly. Now this entire part we will write it over here, integration of 0 to infinity sin lambda into cos lambda x upon lambda into d lambda. So this part is equal to, now over here lambda upon 2 we can write, sorry, pi upon 2, then f of x. Now our f of x, if you see in the question, this is our f of x. So this entire part we can write it over here as it is. This part, this is 1 0 x mod less than equal to 1 greater than 1. So this is our representation. So in this entire video we have seen how to represent Fourier integral. So this is the final answer. So if you like my video, please like, share and subscribe to my channel for more upcoming videos. In the upcoming videos I'll be taking some more examples on Fourier integral representation. So stay tuned. Thank you.